Hi everyone, in today's lesson we're going to talk about how to write the equations of parabolas. Just remember a parabola with a horizontal directrix has x minus h squared equals plus or minus 4p y minus k, and a parabola with a vertical directrix has y minus k squared plus or minus 4p x minus h. So we're going to do a few examples that require completing the square. So we're going to take each of these equations and we're going to put them into standard form. So we're going to put it in this form here. All right. So we have to complete the square. So the first thing that you want to do, just like we've always done, is move over the constant. So the constant is 41. So I'm going to subtract it first. So I have y minus 41 equals x squared minus 12x. And now I'm going to complete the square on the x squared side. So half of 12 is 6. 6 squared is 36. So I'm going to add 36 to this side, as well as add 36 to this side. Okay? So we have x minus 6 squared equals y, and then you're just going to take 36 and subtract 41. And when you do that, you should get 5, or negative 5 rather, and this is your equation in standard form. But just remember that the squared has to come first. So we really want to say it's x minus 6 squared equals y minus 5. Alright, so that means my vertex is positive 6, positive 5. Okay. And since x comes first, we know we have a horizontal directrix, so we know that it's going to open upward. So it's going to look something like this. And the real reason why we know it opens upward is because the number in front of the parentheses here is positive, right? So it has to be positive in order for us to have a horizontal directrix opening upwards. Now, what is the p-value? That's a little interesting. We know in front of the parentheses it's 4 times p. So we can actually make a tiny little equation here, that 4p is equal to 1. And if we divide by 4, we get p is equal to 1/4. All right, let's see if we could try example number 2. So now in example number 2, the y is squared. So that actually is a hint that we have a parabola with a vertical directrix. So now let's complete the square, but now with the y's. So first step is still the same. We're still going to move over the constant. So we're still going to move over the 10. So we have x plus 10 equals negative y squared minus 4y. And we can't complete the square until the number in front of the coefficient of y squared is 1. So we actually have to take out a GCF of a negative 1. And we're left with y squared plus 4y. And then we complete the square. So negative 1 y squared plus 4y. All right, so now half of 4 is 2. 2 squared is 4. So that's going to go here. And whatever I do to one side, I have to do to the other, but I'm really adding a negative 4. So I have to add a negative 4 to this side. So if I combine the like terms over here, I have x, and then negative 4 plus 10 is a positive 6, so x plus 6 equals negative 1 y plus 2 squared. Now technically this still does not yet look like this. It has to be y minus k squared by itself. So we actually have to divide this negative 1 here. Okay, so if we do that and we switch the order around a little bit, we'll get y plus 2 squared equals negative 1 x plus 6. So we know that our vertex is x first, so negative 6, negative 2. And we know that it's a parabola with a vertical directrix, and since the coefficient here is negative, we know that it's going to open to the left. It's going to look something like this. And again, if we want to find the p-value, we're going to set this part negative 1 equal to 4p. And if I divide by 4, I get negative 1/4, but we could also just leave the p-value as positive. Okay, so what I'd like you to do now is try to complete the square for problems 3 and 4. We'll call this homework problems number 3 and number 4, and see if you can answer these questions that follow. I will go over those in the beginning of class tomorrow. All right, let's move on to the back. Okay, so now it says I want to write the equation in standard form given the parts. All right, so given a focus and a vertex, can we find the equation of the parabola? So let's sketch and see what this looks like. So we have a vertex of 2, 1, and a focus of 2, 5. So just by looking at this picture, we know that the focus lies inside the parabola. So we know that my parabola is going to look like this. Okay, so we know that it opens up and has a horizontal directrix. So we know that it's going to be x minus h squared equals 4p y minus k. That's my problem. And we know that p is always the distance from the vertex to the focus, so we can go ahead and count this. So the distance from here to here is 4. All right, so that is going to be my p-value. Okay, so 4 times 4 is 16, and then y, and really the only thing that we need to finish this is the vertex point, which we have. So my vertex is 2, 1, so it goes in as negative 2 and negative 1. That is my equation of my parabola. Okay, let's try another example. I'd like you to do number 2 for homework. Try that one on your own. And I'd like to jump to question number 4. Okay, so question number 4 says a vertex of 6, 3 and a directrix of x equals negative 4. Okay. So with this picture, we know that my parabola is going to look something like this. And it opens to the right, so we know instead of x coming first, it's going to be y minus k squared equals 4p x minus h. So we know that's the formula that it's going to happen. And we know it's positive because the parabola is opening to the right. So if I know my vertex, which I do, it's 6, 3, I can put it into the equation. So it's x minus 6 over here and y minus 3 over here. And the only thing left that we need is the p-value. And remember, the p is the distance from the vertex to the directrix or the vertex to the focus. But I don't have the focus, so we're just going to count the distance from here to here. And that'll be my p-value. So we know that from the origin to here is 6, and we know from here to here is 4, so it's about 10. So to finalize the answer, it's going to be y minus 3 squared equals 40 x minus 6. That is my equation of my parabola. So for homework, you're going to do problems number 2 and problem number 3. These two, and we're going to start there tomorrow as well. All right, don't forget to do the problems on the front page. Have a good night.